So this section is on rational exponents. So far the only way we've written a radical is using just that radical form, right? Yes. Okay, but we can also write them in rational form. Rational form. What's a ration? Is another word of saying like a fraction or a portion. Yeah, good. So when you think rational form, think just like a portion or a fraction of something. Okay, so the example that we have here, we have the square root of 25. Okay, this should just have the square root symbol over this whole thing. So square root of 25. We can rewrite this as 25 to the 1/2 power. Okay, and let me explain why. So, looking at this 25 here, the one that's underneath of the radical, what power is that to currently? Does it have an exponent? No, so anything that doesn't have an exponent, isn't it just to the first power? It's just itself, right? Okay, so that 1 there is going to automatically become the numerator in my fraction, okay? Then I've got to look at my index. What's my index on a square root? 2. The index is always going to be the bottom of the fraction on the exponent, or the denominator, okay? So, let's go ahead and we'll practice this. And real quick, just over to the side on the side notes, what I want you to write, and this is going to go for everything moving forward. If there is no exponent written, if there's not an exponent written, the exponent is 1. So if you just have a number or you just have a plain old variable, go ahead and just get in the habit of writing 1 next to it. Okay? That's going to help us moving forward. So looking at letter A, we've got the cubed root of 125. What power is that 125 to? Yep, just to the power of 1. So I'm going to rewrite this. I'm going to keep that base of 125. And then my fraction, the 1 is going to be on top because that is the exponent that it's to. My index for this one is 3. Okay. Go ahead and try B and C. All right, what'd you put for B? Yep, x to the 3/5. Good. So the 3 is the power that it's currently to, so that's going to be the numerator. Index is 5, so 3/5. Good. What about the square root of 10? 10 to the 1/2. Good. Get used to writing a 1 next to that 10 because I know it's to the first power. Anytime I have a square root, my index is going to be 2. Okay? Questions on those? All right, moving right along here. Now we're going to do the opposite, okay? So we're going to take it from the exponent form, right, the rational form, and we are going to put it in radical form, which means just in a radical, in a root, okay? So looking at the first one, it is 5 to the 1/2 power. So, keeping my base of 5, I know it's to the first power, right? And then what kind of root am I going to have? What's my index? 2, so it's just going to be a square root. You don't have to write the 1. No, but you can. I would get in the habit of writing the 1. Okay. And then we've got 16 to the 1/4 power. Try that one. What is it? What'd you get? Or 4th root of 16. Good. Everybody got that one? Okay. Looking at number C. Letter C, whatever. We got 2.5, or 2 to the 1/2 power, times 8 to the 1/2 power. Be careful on this one. Are the bases the same? No. So didn't we say whenever we're multiplying numbers like this, we have to have the same bases to be able to add those exponents, right? Remember that? So I couldn't have like x to the first times y to the first. I couldn't like add those exponents together because they're not the same base. You with me? Okay. So the 2 and the 8 here are not the same base, which means that I cannot just multiply them. Instead, I'm going to go ahead and put these into radical form and then see how to multiply them. Okay? So 2 to the 1/2 is going to be square root of 2. I'm still multiplying. 8 to the 1/2 is going to be square root of 8. Okay. Now does this look like something I can multiply? Yeah, because they have the same index, right? So what is square root of 2 times square root of 8? Uh-huh. Can I simplify square root of 16? Yeah, let's try to break it down. What do we get? 8 and 2, 8 breaks down 2, 4 and 2, 2 and 2, and I'm looking for groups of, how many do I have? 2. So what does this become? Yep, 2 times 2 is just 4. My answer is 4. Okay, so make sure you make a note of that if you need to. If the bases are not the same when you're multiplying, you've got to change it to radical form first. Okay. So now we're going to be dealing with simplifying rational form. So it just wants us to write the following in the simplest form. So we're going to convert it into radical form, okay? And then we're just going to simplify it, just like we've been doing this whole time, okay? So this first one, 25 to the 3/2 power. How would I write that as a radical? Okay, so underneath my radical, I know I'm going to have 25 to the 3rd power, right? And then my index is 6. Or sorry, not 6, it's 2. Yeah, so it's a square root of 25 to the 3rd power. You with me? Okay, I don't necessarily have to write that 2 there on the index, but I'm just going to leave it for now. So to simplify this, you could go ahead and you could take 25 to the 3rd power, get that number, and then break that number down. But what do I also know? 25 to the 3rd power, isn't that just 25 times 25 times 25? Yeah. And then what does 25 break down to? 5 and 5, 5 and 5, 5 and 5. I'm looking for groups of 2. And how many do I have? 3. 1, 2, 3. So this is just 5 times 5 times, which is 125. And that's my answer. Questions on that? Okay, let's go to the next one. This one's weird. It's x to the 2.5 power. X to the 2.5. I don't like decimals, okay? So I want to convert this to a fraction. 2.5 as a fraction could be what? Say what?
2.5.
Yeah, 2.5, okay? Write that as a mixed number. So 2.5 would also be 5 over 2, okay? So I'm going to change this 2.5 power to just 5 over 2 power. So now what I've got, so I'm going to write my radical symbol. What's going to go underneath of it? X to the 5th, because that's the numerator. And my index is going to be 2. So I can write it if I want to. I don't have to. If I have x to the 5th, how many x's is that? 5. 1, 2, 3, 4, 5 being multiplied, right? How many groups of 2 is that? 2. So that's just going to be x squared. And then what's left? Square root of x. And that's my answer. Okay. Questions so far? All right, let's go for letter C here. X to the 3/8. How would I put that? X to the 3rd. 8 is going to be the what? The index. Okay. Yes, good point. You are just going to leave this one. Why am I leaving it?
Because there's no way that there's that many x's to go in.
Yeah, there's not any groups of 8 x's, right? There's only 3 of them. So I'm just going to leave that alone, okay? A lot of students will get to this point and then they'll think that they did something wrong, so they'll switch the 3 and the 8, okay? Don't do that. Always know that the top part, the numerator, is going to be what your exponent is underneath, okay? And then the denominator is going to be that index. So sometimes you don't have to work them out. Those are the nice ones, right? Okay. Let's keep going. This is just a review of all the rules that we learned last class. So I'm actually not going to go through these, okay? But you should know them, and if you need to write those in there, you can go back to your notes: multiplication, power to power, negative, division, rule of 0. Okay, so now we're going to get into a little more complicated examples, but we know our rules, so we're going to be okay on this. First thing I'm going to do here, again, anytime that I see something without an exponent, I'm just going to get in the habit of putting a 1. So 27 to the 1st power, right? It doesn't have an exponent. X squared, and then that's all in parentheses being taken to the 2/3 power. Okay? So the whole thing in parentheses is being taken to the 2/3 power, correct? So I'm just going to write it like this. So 27 to the 1st, x squared. What's my numerator? 2, so I'm going to write a 2 right there. And my index is 3. Okay? I know that I can simplify what's underneath of that radical, right? I can make that a little prettier before I start breaking it down. Yeah. So I'll keep my radical symbol. This is when we use that power to a power rule, correct? Power to a power rule, always do that first. So 2 times 1. 2, right? And then 2 times 2. Yep, x to the 4th. Okay, so once I had it in my radical, I just did power to a power rule to simplify that. Now that looks like something I can deal with, right? Yeah. So I could do 27 squared in my calculator, get that number, and then start breaking it down, or I could just know that 27 squared is 27 times 27, right? And then just start breaking it down from there. What can 27 break down to? Say what? 9 and 3. Yep, 9 breaks down to 3 and 3. 2 groups of 3. Perfection. Do I have anything left in the numbers? No. You used all of them, right? So 3 times 3, I'm going to write out front of my answer. What about these x's? How many groups of 3 do I have? 1. So I'm just going to put a 1x, or x to the 1st. Okay. Anything left?
Yeah, the x.
There's 1x left, right? Because I had 4 and I only needed groups of 3, so I had 1 left. So what do I need to do with that one? Yep, it goes underneath of my radical. Good. Can I make this a little bit more simple?
Yes.
By what? 3 times 3, which is 9x cubed root of x is my answer. Okay. Questions on that one? Okay. Let's go to the next one. Example 2. Go ahead and just set this one up in radical form. Okay, so currently it's in rational form. Set this one up in radical form. Okay, how'd you do it?
First I did the, put 4 in square root parentheses 3y parentheses to the power of 3.
Raise your hand if you agree with that. Good, that is correct. So 3y to the 3rd power underneath of the 4th root symbol. Good deal. Okay, now, what comes first here?
Well, usually the 3 times is inside.
Yep, so this first coefficient here, 3, what power is that to?
First,
The first. What's y to?
the first.
The first. Okay, so now I can distribute that 3, just like she said. So I'm going to end up with 3 to the 3rd, y to the 3rd. Good. 3 times 1 is 3, 3 times 1 is 3. Everybody understand how to do that part? Okay. Now we can try to simplify this. 3 times 3 times 3, y times y times y. I'm looking for groups of 4. Do I have any?
No.
No, I do not. Okay, so this one cannot be simplified. The only thing I can do, though, is should I leave that as 3 to the 3rd? 27. Yep. I'm going to make that into a 27. But that's the only thing I can do on that one. So that'll just be my answer. Okay? Good deal. Questions on that one? Okay. Let's keep going. All right. Looking at this one. What do we got here? We got a fraction, right? We're dividing, okay? So on top, we've got a negative 23 being taken to the 2nd power. And then on the bottom, we've got a negative 23 to the 7th power to the 5th root, okay? There's a really long way I could work this out. But there's also a really easy way I could work this out. If I know, well, first off, let's just look at the bases on both. Are they the same? Yeah, this negative 23, right? And if I think about my quotient rule, if my base was the same, couldn't I just subtract the exponents? Right? If we were dividing, if my bases were the same, we were dividing, I could just subtract the exponents. So if on top I've got my base being taken to the 2nd power, what's that base being taken to on the bottom? If I rewrote it. You see what I'm talking about? Can we rewrite this as a fraction? Or to a fraction?
Could be like 7 over 5.
Yeah, negative 23 to the 7 over 5. Everybody see that? Okay. So now I've got that quotient rule. Can I just do 2 minus 7/5, right? Keep my base. And then do 2 minus 7/5 to figure out what my new exponent is. Do y'all see that? Okay. So 2 minus 7/5. You could plug that into a calculator. If I wanted to do it by hand, I would just need to make 2 have a base of, or a denominator of 5, so I need to multiply it by 14 over 5. So that's the answer. Okay. So this is the same as 10 over 5, right? Yeah, I think 3/5 is going to be our answer there. You with me on that? Do you see how I did that? I made that 10 over 5. Or you could just plug it in your calculator, 2 minus 7/5, and get 3/5. Did anybody plug it in their calculator? And you got that?
Yeah.
Okay, good deal. I would do that. So it's negative 23 to the 3/5 power. Okay. I don't know how to simplify something that's written like that, but I do know how to change it back to radical form. Okay. So I'm going to do that. How do I do that?
You just put like the square root of 5, and then would it still be negative 23? Can't have that.
Yeah. Mm-hmm.
So negative 23, and then the square root of 3.
So like that, to the power of 3?
Yeah.
Under a
sorry,
5th root?
power.
No, you're good. Okay, good deal. Jordan brought up a good point. Why is it okay for me to have that negative there?
Odd index.
What'd you say?
Odd index.
Yep, odd index. Okay, it's an odd index, so I'm good on that. And it's being taken to an odd power. Okay. All right, so now we can break this down. We've got negative 23 to the 3rd. I could multiply that out, or I could just know that this is negative 23 times negative 23 times negative 23, right? Okay. Do you think 23 simplifies? No, I don't. Okay, you could try it, but it's not going to. So I'm looking for groups of 5, and I definitely don't have that. I just got 3 of them. So what if we just left this as our answer? You think that'd be okay? Yeah. Good deal. Okay. Questions on that one? All right. We're getting close. 2 example 4s. I don't know how that happened. Okay. When we're multiplying, what was the rule on multiplication? Yeah, normally you would add, right? But are these like bases? No. So can I do that? No, probably not. Okay. But we can go ahead and change them to radical form, right? So let's do that. So change a to the 5/3 into radical form and multiply that by b to the 4/3 in radical form and see what you got. Okay, so a to the 5/3. How'd you rewrite that one?
A to the power of 5 square root of 3.
Good. A is to the power of 5. 3rd root. Being multiplied by b to the power of 4 underneath of a 3. A cubed root. Okay. So now, can I multiply these values?
Would you like,
I think so.
you have the same?
Yeah, why do you think so?
You have the same index.
They have the same index, right? So we can multiply these. So a to the 5th times b to the 4th, isn't it just a to the 5th, b to the 4th?
Yeah.
Yeah. Okay. And now I'm looking for groups of 3. Do I have any groups of A? How many? Just 1. How many groups of B? 1. And then what's left over? 2A and 1B. Okay. So that is my answer on that one. Good deal. Questions on that? Okay. Next one. So, looking at these, do I have the same base underneath?
Yeah.
Yeah. Okay, so that's good. Okay. I'm multiplying the radicals though. I said that to multiply, don't we have to have the same index? Isn't that what Mason just said? Are these the same index? We're gonna try, yeah. So since we have the base, okay, we can't multiply it as it is, but I can rewrite these in exponential form, right? Let's try that, okay? So this first one is just gonna be 2x to the what? So it's currently to the first power, right? 1/5. Okay. So now what we've got, we're multiplying that. First we've got to deal with what's inside these parentheses. What is that? 2x to the... Well, first off, just the parentheses. Yep, it's 2x to the first over my index, which is 3. Do we all see how that's the inside of those parentheses? And then it's being taken to the second power. What's that going to do here? Multiply them, okay? So I end up with just 2x to the 1/3 times 2. Just 2/3. So now I've got 2x to the 1/5 times 2x to the 2/3. And when we're multiplying, we look for the same base, right? And we have that, right? Yeah. So we can keep that. And then we do what with those exponents? Add them, right? So 1/5 plus 2/3. 1/5 plus 2/3. 13/15. Okay. So now, can't leave it like that, but I can rewrite it as 2x to the, and what's my index? 15th. Okay. So the 2 is currently to the first power. X is also to the first power, correct? So this is the 15th root of 2 to the 13th, x to the 13th. That is going to be my answer. The only thing I could do is simplify that 2 to the 13th, right, with my calculator. Okay, I could do that, but that would be the only thing. Okay, moving right along, we're almost done. We've got a little bit of time left. So simplifying the following and understanding what parentheses do and what they don't do. So looking at the first one, don't have any parentheses, right? Okay. Looking at the second one, do I have any parentheses? No, but what's different about the second one than the first one? Yeah, the exponent's negative, right? And then what about number 3? What's different about that? Parentheses and a negative exponent. Okay, so let's just see how these different things change. So looking at the first one, if I were to write this, so the 25 is to the power of 3/2, correct? What about that negative out front? Is that being taken to the power?
Yes. Wait, no,
No, why not?
because the index is even.
It's not about the index, but is it in parentheses? So it's not technically a part of that 25 to the 3/2. So get in the habit of, if you see a negative with no parentheses, just make it -1 times whatever that value is. And I'm going to write that over here. So if there's a negative out front, not in parentheses, make it -1 times your value. Okay, so now we can break this one down pretty easy, right? 25 to the 3/2 is just going to be 25 to the 3rd power being square rooted, correct? Yeah? And I have -1 times that. So I can break down 25 to the 3rd. It's just going to be 25, 25, 25. 5, 5, 5, 5, 5, 5. Looking for groups of 2. And I've got 3 of them, right? Okay. So 5 to the 3rd. So 5 times 5 times 5 is what? 125. So what I have is -1 times 125. What is that? Good. That's my answer on that one. Everybody with me on that?
Let's say 1, 2, 5.
Yep, 125. 5 times 5 times 5. -125. Okay, so now, looking at that one, we said what was different about the next one is that the exponent was negative, correct?
Yes.
So if I've got, again, get used to pulling out the -1 first. So I've got -1 times 25 to the -3/2. What do I need to do about that? Can we have a negative exponent? No. I need to flip it, right? So this just needs to become -1 times 1 over 25 to the 3/2, right? You with me on that? Because we said no negatives up top. We're combining all these rules. Okay. What did we say that 25 to the 3/2 was?
125.
It was 125. So this is just going to be -1 times 1 over 125. I'm not going to work that out again. And what's the answer going to be? Perfect. -1 over 125. So we see how that negative exponent changed that. Okay. Now the last one, and then we're done. Got about 2 minutes left, so right on time. All right. We said this one's different because the parentheses, right? So the negative is included in this exponent, correct? Okay. So first off, we can't pull the -1 out, but we do have a negative exponent, which means I need to flip it. Yep. So put this in the bottom to make that exponent positive. So now I've got 1 over the cubed root of -25 squared. Yep, so that's going to end up being -125 since there's a negative there. Do we all understand that? Okay. So this is still going to end up being the same answer as the one before. -1 over 125. Okay, homework.